Welcome back to our Hyperledger Besu development series, where we are learning about how to create private network using multiple consensus. In our last video, we have discussed about how to create a private network using Ethash consensus. In this video, we are going to learn about how to create a private network using Clique consensus, which is POA based consensus. So let's get started. We are just following official documentation for it. Here you can see how to create a private network using Clique. So we have to follow these steps. In our first step, we have to create empty directories. I have already created this folder structure, empty folder structure. Here you can see in Clique node 1, node 2, node 3, three folder directories are there. Inside that, one data folder is there. So let's go to the second steps. Here we are we are choosing node 1 as an initial signer. So in order to do that, we have to create a keys for it. In order to create keys, we have to copy this command and paste it in node 1 directory. Using this command, we have created node 1 address and its key. It is working as an initial signer for our network. After that, we have to create one Clique Genesis JSON file in our main directory, which is Clique. Just paste this Genesis JSON file in our JSON file. Here you can see in our Genesis file config engine is Clique engine, which is POA based engine. POA means proof of authority based, where signers are there. Here you can see extra data is there. 3 wallet addresses also there, and same like previous Genesis, only engine is different, working is different, and extra data is there. In Ethash Genesis, extra data is not there. In extra data, we have to add our node 1 address, which we have created by that command. So this node 1 address, we have to add it in Genesis file. Just remove this 0x. That's all. In our next step, we have to use this command to run first node, our first Clique consensus based node using Besu. Just copy this command, paste it in our node 1 directory. Here you can see our node 1 is running successfully. Let's go to the documentation. Similarly, we have to run node 2, node 3 as well. Same like Ethash, we have to add inode URL in node 2 command. Just copy inode URL from this terminal, node 1 terminal, this inode URL. We can fetch it from JavaScript console also. We can take it from here also. Let's redirect to node 2 directory. S3 directory. Copy our inode URL in copy and paste our inode URL in this command, which is for second node. Copy this command and paste it in second terminal. Here you can see second node is also running successfully. After that we have to run third node as well. Same, we have to just update one port. Instead of 46 we have to write 47, because each node is running on separate port. Let's paste it there. Yeah. So what is the problem? Let's copy node 1 URL again. Got it. In our previous command we have updated only this one port, but we didn't update this peer-to-peer port. That's why it is showing error. Now it will work properly. Yeah, it is working properly. Here you can see block imported 16, 17. Here you can see node 1 is the initial signer, so it is producing the blocks, and another two nodes are the is acting as a soft node, which is importing the blocks. So let's check the transaction. Before that I have to explain one more point. Here in extra data we have to always add the node key. We can use different addresses here, but for now we are just following our Hyperledger Besu official documentation. That's why I am using same addresses. You can also use same addresses for testing purpose. For production we have to change everything. We can customize the genesis also. Let's check a transaction. Here you can see FE3B 200 test token are there. In our last video we have imported the Ethereum in our MetaMask wallet. So let's check the allocation. In our Genesis file you can see we have allocated some fund. It is 200 ETH or 200 tokens. It is in hex format. So let's do a transaction. To query the transaction we have to use our light blockchain explorer. I have explained it in our last video as well. We are using test network. Here you can see 25 blocks are there. Let's check in our terminal also. Yes, here you can see 26 block is there. Here you can see 26, 27. Let's do a transaction to check whether network is working or not. Let's transfer one token to another address. Gas estimation is also working properly for Clique network. Let's confirm the transaction. Can check it in terminal as well. It will take some time to get completed. Because as we are using a local system, sometime it will take time for transaction. If you facing same error in your system, let's go to the advanced setting and clear activity logs. Because in our last video we have used same network, maybe that's why it is not showing. Let's do transaction again. I have cleared all activity logs. Maybe now it will work. Yeah, here you can see transaction is successful. As previous transaction also successful. You can query the transaction. You can see value 1 ether means 1 token, transaction hash, block number, all the transaction related data. So this is a light blockchain explorer. We can use it for all EVM compatible blockchains. In order to run this explorer, we must have a MetaMask installed on our system. It is a requirement for this explorer. That's all for this video. We have successfully created an Clique consensus based private network where node 1 is a initial signer and node 2 node 3 acting as a soft node. This is the custom genesis file for Clique consensus engine POA based blockchain. That's all for this video. In our next video we are going to create a private network using IBFT consensus, where we are going to use IBFT engine, and we are going to add multiple validators. As here in our Clique consensus we are allocating node 1 as a initial signer. There we are going to use different signers for each node. That's all for this video. Do follow for our next video. Thank you.